So two things in this section. We're going to do greatest common factor and least common multiple. Greatest common factor is a real pain to write over and over and over. So we abbreviate it with 3 letters. That would be
GCF.
Nice. Capital G, capital C, capital F. So GCF, greatest common factor. And going back to yesterday, factors, those are the numbers something is divisible by. And by divisible by, we're saying these are the numbers that you could divide something by and not get a remainder, not have anything left over. Fair enough? So this isn't the factor tree thing we were doing at the end of the notes before. That's figuring out just the prime factors, just the prime numbers that you'd have to multiply together to get something. This is kind of more that rainbow method, figuring out all the different numbers that you could divide something by. So factors, it's not the factor tree or prime factorization. It's not this here. Factors are all the numbers. We're going to do the hashtag for number. So all the numbers you could divide the number by. So all the numbers you could divide the number by. Maybe I'll say without a remainder. So all the numbers you could divide by and get an integer answer, get a number without a decimal answer. So I'm going to look at kind of 2 different ways to do this. And for some types of numbers, you might find one way is better than the other. You might find you have a preference and you do them all the same way. It's kind of up to you. But one way is to list all the factors of the 2 different numbers. And by that, we called that the rainbow method. So the rainbow. And we'll do an example of this too. So the greatest common factor equals or is the largest number that's a factor of both numbers. So in other words, if we were to have this greatest common factor of 30 and 48. So greatest common factor, the largest number that's a factor of both numbers. So I'm going to figure out, okay, what are all the factors of 30 over here? What are all the factors of 48 over here? So we could say 1 and 30, yes? So, because 1 times 30 gives me 30. 2 and 15. And 30 is also divisible by 3. That would give us a 3 and 10. So now, is it divisible by 4? If you're thinking like multiples of 4, you have like 20, 24, 28, and then 32. So it's not divisible by 4. How about 5?
Yeah.
Yep,
Yeah.
so 5 and 5 times 6 gives me 30. So 5 and 6. So the reason we called this the rainbow method was sometimes people went through and did like the little line. So 1 and 30, 2 and 15. There isn't really much point in writing these. I'm going to erase them in just a second anyways, but 5 and 6. But they kind of connected the pairs. Fair enough? So that's what I meant by rainbow method. So we had those. All right, if we do the same for 48, we could say 1 and 48. That would be a pair. Agreed? 2 and, who's feeling smart? 24. Nice. So 3. Well, we could check and see if it's divisible by 3. 4 plus 8 is 12. Can you divide 12 by 3? Yep. So we know 3 works. So 3 times what gives me 48? So you could try to think it through. You could just quick go over on the side, say 1, pull down your 8. 3 times 6 is 18. So it'd be 3 and 16. Fair enough? Minus 18 gives me a 0 and so on. So I'm going to get rid of this thing here. But so 3 and 16. 4. I bet you could do that in your head. 4 and... Nice. 4 and 12. Is 5 going to work?
False.
Nope, 5 doesn't work. 6.
Yeah.
6 and 8. Good. And 8. So we're kind of running out of space. So the only other option would be like 7 times 7. Doesn't work, right? Okay. So 7 and 7 doesn't work. So again, you could, if you wanted to, do like the little rainbow things, but I'm going to skip those. All right, so now we're just looking at what's the biggest one they have in common. Because you could say 1 and 1. It's a common factor, or 2 and 2 are, but those aren't the biggest ones, right? So the biggest one, I'm going to kind of start here at my 48. So 48's not in the other list. 24's not. 16's not. 12. I'm kind of looking over here for each one. 12. Okay, you guys are beating me there. So 6. So 6 is the biggest number that's in both lists. So you could say that GCF equals 6. This way, I think, works well for small numbers. So you get to 30 and 48, I'm getting to the point where I'd do it the other way personally. I think it'd be faster. But there's nothing wrong with this way. But if you have like things like a 10 and an 8 or something like that, this is probably going to be by far the fastest. Fair enough? Way number 2. Do the prime factorizations. That was the factor tree thing. So we're doing factor trees for both numbers. And then the GCF equals, I'm going to say, the product of the common prime factors. So the product, when we say product, are we adding, subtracting, multiplying, or dividing?
Multiply.
So I'm going to put a little mult in parentheses. So the product, or you multiply, of the common prime factors. So the factor tree gets us down to all the prime numbers that you can multiply together to get that number. So we're trying to figure out what do they have in common. So we'll do this here. So it'll be these same two numbers, and you can decide, do you think that this way is faster or slower for you? What if we do 30? We could break 30 into 2 and 15. And we could break 15 into 3 and 5, or 5 and 3. So do you agree our prime factors for 30 are going to be 2 times 3 times 5? So we're done with that one. Now we jump over to the 48. 48 we could break into what and what?
8, 6.
So I usually do 2 and 24, but we could do like a 6 and an 8. There's nothing wrong with that. But now neither of those are prime. We could break 6 into
3, 2.
Yep, so I'm going to do 2 and 3, or 3 and 2. So those are both primes. I'm going to factor them just so I don't kind of lose them in the mess. And now the 8, we could break 8 into
4 and 4.
4 and 2, I think I heard. So 4 and 2. So 2 is another prime number, but the 4 we could break into
2 and 2.
2 and 2. So we ended up with a 2 to the 4th times 3. Yes, because we have 4 2s. 1, 2, 3 4s. 2 to the 4th, and 1, 3. And now what we're doing is we're looking for what do they have in common. Well, this one has 1 2. This one has 4 2s. 2 times 2 times 2 times 2. So how many 2s do they have in common? 1. So they have a 2 in common. This one has 1 3. This one has
1, 3.
So they have a 3 in common. And this one has a 5. This one,
Does not.
no 5. So do you agree 2 and 3 are the only ones they have in common? They both have 1 2. They both have 1 3. And 2 times 3 is
6.
6, which is going to be that greatest common factor again. So we have the same answer as what we did up above. Both of these we had a greatest common factor of 6. It's just a matter of figuring out which way you prefer to do it. So, oops. Yeah, you can flip the page. So either one of those are going to work for any set of numbers, but if you're only going to learn one, learn way number 2, because that'll work with the really big numbers much easier than way number 1. So, all right, so if we do least common multiple, everybody ready for the second thing? Okay. Least common multiple, if we had to come up with an abbreviation, you would probably pick
LCM.
LCM for least common multiple. And so say we're trying to find the least common multiple. Well, okay, it's a little ahead. Multiples of 5 would be things like 5 and 10,
15, 20,
dot, dot, dot. Multiples of 3 would be 3,
6,
9, 12, dot, dot, dot. So we okay on multiples?
Yeah.
I figured I just would start there so I wasn't like losing people. But for these, you could say like this is 5 times 1, 5 times 2, 5 times 3, 5 times 4, 3 times 1, 3 times 2, 3 times 3. Or basically you start with the number and then you just add 5, add 5, add 5, or add 3, add 3, add 3. Yes? So, probably been doing those for years. So the least common multiple is the, anyone? Smallest. Because it's least, we're kind of switching gears from the first half of the notes. The smallest number that is a multiple of two different numbers. And it'd be possible to find the least common multiple of 3 or 4 different numbers, but we're not doing that this time around. So for this, there's several ways you could do it. One is just going to be to list them out. So if we were to say, all right, so for 5, stick with green. So 5, we'd have 5, 10, 15, 20, 25, and you could keep going, right? Sometimes what I'll do is I'll pick, like, I recognize multiples of 5 because they all end in
5.
Or
0.
5 or 0. So then what I probably would do if nobody was watching is just start with my 7s and do 7, 14, 21, 28. And I would just keep going until I get a number that ends in 5 or 0. If you're not sure, you can just kind of keep doing both lists. So 35, 42. Then you could jump back to the other list and say, all right, 30, 35. So you could just kind of keep extending both lists out until you find a number that they have in common. So for those, the least common multiple is going to be 35. Good? You probably did this last year. I'm told there's a lot of repeat, but I've never taught 6th grade math at this point. But if we have the 12 and 16, 12, 24, 36. So first number goes up by 1, second number goes up by 2 every time. So, all right, so I have 48. This is a little bit messed up because my 2 gets me up to 50. 10 more gets me up to 60. And now you can go back to the first digit goes up by 1, second digit goes up by 2, 84, and so on. Okay, now if we do the 16, 16 times 2 is 32. That would be 48. Next one would be, so 8 plus 6 gets me 54, plus 10 more gets me 64. So you could keep going, but some people maybe already see the least common multiple is
48.
So they both had 48, so we could have stopped there. So 48 is going to be the least common multiple. Good? Yeah, there's homework. Homework is there. You should be able to do these kind of questions without a calculator, but some of the book ones, calculator would be kind of nice. So maybe here's a quick way to go and come up with the multiples using your calculator. For this top one, you could have done like 12 plus 12 plus 12 and so on. But if you have a calculator that on the screen will do ANS for answer, when you do like just plus 17 or something, if you do 12 and then hit your enter key, and then do like the plus button and then like 12 again. Now every time you press enter, it'll give you another multiple of 12. So go ahead and try that, and it should give you, every time you press enter, it'll go 12, then 24, 36, 48, and so on. If your calculator doesn't do this answer key thing, then to do multiples of 12, you do 12 plus plus, and when you do that, you probably will have a little K showing up on the screen along the top. And then I believe after that, you could either do your 12 again, or maybe even just press enter, but go and then hit enter a bunch of times and see if it cycles through the 24, 36, 48, and so on. Let me know if you have questions.